Let's investigate a two-tailed hypothesis test problem using T. Consider bowling scores, and I know you guys are avid bowlers, so that's why I did this. A sample of 25 bowlers use visualization. Their mean score is 85.6 with a standard deviation of 22. We hypothesize that visualization affects scores. So here's our old friend, the two-tailed hypothesis again. Not predicting an increase or a decrease, but just an affecting. What are the null and alternate hypotheses for a two-tailed test alpha of 01? Holy cow, that's stringent. Well, as you can see, I go down to the null hypothesis, and it just says, wow, visualization doesn't do anything. It doesn't affect scores at all, so therefore that I would expect the mean to be 90. And conversely, the alternative hypothesis says that visualization affects it somehow. And I don't know how. It could lower it, could raise it, but it affects it somehow. And you'll notice here we actually did lower it by an eyelash. So here we go. Let's set the degrees of freedom, which are 24, 25 minus 1. And here are my critical values of T, plus and minus 2.797 with an alpha of 01. Is that true? Well, here we go. 24 degrees of freedom. Two tails combined, alpha of 05, or pardon me, it's 01. Two tails combined, alpha of 01. Follow it down, 2.797. Absolutely. So in that case, I've got the right value, 2.797 plus or minus is my critical values. Absolutely. And then I'll do some math. I've got everything I need, the standard deviation and the sample mean and the population mean. Plug in my sample standard deviation, plug in my sample size, 22 over radical 25, 22 over 5 is 4.4. Here's my obtained value of T. The sample mean of 85.6, the population mean of 90, divided by that estimated standard error. Holy cow, it's negative 4.40 over 4.40, negative 1. So where does that fit? Well, in this case, I failed to reject the null hypothesis. Didn't even come close. I got a T obtained of negative 1. So in that case, I failed to reject. It's a no-brainer. There's really nothing to concentrate on here. What contributed to this? I had a weak effect of only 4.4 points, and also not for nothing, we had a fairly large standard deviation, which didn't help. That blew up the estimated standard error, which interfered, you could argue, with the t-test. What about an effect size? In this case, I just plug in numbers, capital M minus mu over the sample standard deviation, 85.6 minus 90, divided by 22, and I get 0.20. That's a smallish effect, which again suggests that visualization was not too hot. It just didn't do much for bowling scores. And of course, here's the rendering of the hypothesis test again. So it just wasn't a very strong effect at all. So we got a smallish effect size. And by the way, I'm always ignoring negatives, even if they come up with in the context of Cohen's d. What about r squared? Now you remember that's the t squared, that's the obtained t, divided by the t squared plus the degrees of freedom. Now what happens when we square a negative? It's always positive. So negative 1 squared is 1. Negative 1 squared plus 24 is 1 plus 24 is 25. And I got an r squared of 0.04. How do I interpret that? Well, only about 4% of the variance in bowling scores was accounted for by visualization. That's it. That's not very much. Although with a manipulation like this, that might be pretty good. Who knows? Hard to say with visualization type things in sports psychology. So it's fairly, and again, I'm always using, even if the degrees of freedom don't appear in the table, I always use the exact degrees of freedom here for r squared, which is fairly easy to do. So the way your text describes this is they would say only 4% of the variance in scores was accounted for by the treatment. What I like to say is the variance in the dependent variable bowling scores was accounted for by the independent variable, which was visualization. So there's that. And I really think that's about it for Chapter 9. I did not mention Type 1 and Type 2 error in Chapter 9, but the principle holds. If we rejected the null hypothesis, we could have made a Type 1 error. That's not to say that we did, but it's possible. Conversely, like this, if I failed to reject a null hypothesis, I might have made a Type 2 error. But again, that's no suggestion that I actually did. But you'll see most of the concepts and the ideas with respect to proceeding along the lines of a hypothesis test are largely shared, irrespective of whether we're using Z or using T.